Hey guys, and welcome to this week's main video. Today's going to be a special video, and it's going to be the first of many to come coding challenges. This is going to be a longer form content where essentially we take a particular thing we want to code and we just sit down and do it from scratch. So that's going to be today's longer form video, and maybe in the future these will be done through live streams, but right now my mic has basically died, so I'm having to boost the audio quite a bit just to make it audible. Today we're going to be recreating a color vibrance plugin from Video Copilot. We're not going to be recreating it step by step for each of the properties, but we're going to be basically going over how we can create the color tinting effect and some other things like changing the brightness and gamma, and also dealing with alpha values. Now, I haven't pre-prepared this or anything because this is all just going straight through from duplicating the skeleton plugin project to hopefully creating this working plugin. I'm going to be going over all of the process, and hopefully it will just be a good insight. It might be a speed run, or it might be quite long, so we'll find out. Before we get started, I do want to remind you down below, hit subscribe and the bell icon to be notified of new videos when they come out. And in the description, you can get the code for this once I upload it onto GitHub and check it out for yourself. Use the plugin if you want, if it works. And then in the description as well, you can follow me on Instagram to get updates there. And if you're not a member of the Discord server, I recommend coming on over and getting help with scripting extensions, plugins, and expressions. I don't quite remember who exactly asked this, but someone in the tutorial ideas, I believe, or somewhere else asked if I could make a color vibrance tutorial. So this is kind of the way we're going to go through with that. And then let's just go ahead and get started. I'm going to first go into my preferred After Effects SDK folder, and we're just going to use the skeleton project, and let's make a, what are we going to call it is the first question. We obviously can't use color vibrance. We can just use, we'll call it vibrancy. That'll be a good name for now. And what I'm going to do is just copy the skeleton project over. Oh, this is actually like a not good skeleton. So I'm going to take mine from CC 2015. Copy that. And let's make vibrancy. Now, since this is going to be a longer form content, I'm going to probably be explaining things quite a bit more. I'm going to go ahead and run Visual Studio as an admin. And the next step is to set this up for how we want. We can kind of discuss maybe the features we need first and how we're going to achieve them. Let's go ahead and start with that. We'll just list out the UI parameters we want to use. So let's go ahead and say vibrancy params. These are going to be the user interface params. We're going to need a color. I use UR, deal with it. A vibrance could kind of just be the intensity controller for that color. And then I also want to include, that's kind of like the brightness, so let's do two more. We'll do a gamma, and we can fill background with black. So what that's going to hopefully do is if you have like a transparent element, it will just take anything that has less than a full 255 alpha channel that's full, and it will make it totally transparent. I think that should be good. Now for how we're going to achieve these. So the fill background is relatively easy to think about. Like I just said, if we have an element with transparent background, we can go through each of the pixels in our composition or in our layer that has the effect applied, and what we can do is check if the value is not the maxed out value for that channel, the alpha channel, which means if it has a little bit of transparency, even 1% transparency, we want to fill that with a black background. And for a gamma, I've already done this multiple times. It's a very similar thing where you just iterate over all the pixels and use a simple power. I think it basically a power to 2 or something like that. We'll look up the math, and that applies a gamma effect to all your pixels. And then for the color and the vibrance, there's a number of ways we could approach this, and we kind of have to decide, are we going to use some kind of additive tint, or are we going to use some kind of conversion tint? And what I mean by that is, do we want to add color on top of the pixels that are already there, or do we want to totally change the original colors to whatever that is? I'm not entirely sure, obviously, how Video Copilots works because you can't see the code, but we can kind of make the assumption that with how good it looks, it has a smart enough programming in it that the luminosity is affected differently with a tint. So if you tint something blue, the dark spots are going to be even darker blue, and the brighter spots of the image are going to still be slightly whitish and less dark blue. So it doesn't need to just flat out tint everything the same tint. It needs to kind of fall into line with the luminance as well. And I think we can achieve that with any method. But with this being said, we can go ahead and open up the project I just duplicated, and we're going to go ahead and change all the file names and parameters to match what we want. And I'm going to start with the names of the files here. We're going to change it all from skeleton to vibrancy. So just hitting F2, vibrancy, we'll go through here and change everything to vibrancy. And then we're going to need to go into all the files, change the effect match name, and also change any of the references to these files that once had skeleton or something else. So you can see it references skeleton.h. I can hit Control-Shift-H to bring up replace in files. I'm going to replace any instance of skeleton with vibrancy, match the case, replace them all. And then I also have some instances where it's all caps skeleton, which I'm going to want to replace with all caps vibrancy. And I'll just go ahead and save all this. That should start looking better. Inside my R file, which contains all your base plugin information, I want this to be called Vibrancy. We're going to put this in NT Productions. Instead of Adobe Vibrancy, I'll just say NT Vibrancy. And that should be good for that. I believe inside my H file is good. Looks like we have some errors here. It's referencing vignette still. We'll just change that manually to vibrancy. And let's see if we can build this. Actually, we need to check our build settings, so I'll right click on my project, not the solution. Make sure I'm in my active mode and I'm debugging. I've got my output directory already set up to put that into my plugins general folder, but for debugging I need to change the command to the After Effects launch shortcut. So that way when I hit debug locally, it's going to launch Adobe After Effects. So let's see if this builds. Control-Shift-B. And yes, that looks like behavior of a successful build. Next up, let's set up our parameters here. We first, in our header file, need to change our enumerations for these. So instead of gain, we want color. For that, we want the vibrance. We'll add 2 in here. Vibrancy underscore gamma. Vibrancy underscore fill BG. And then we need to also have these down here. We'll rename them so they match. Color disk ID, vibrance disk ID, gamma disk ID, and fill background disk ID. And we can also change our structure here. Instead of using the gain info, I'm going to change the name to vibrancy info. Just replace that in here. And now we're going to fill this with what our properties are going to be. If we want this to work in 32 bits, which I think we'll do, we need to make sure we have these in our structure here so that we can move them from pre-render to smart render and all that. So we'll want a color object for each bit depth, 8, 16, 32. So we'll want a PF pixel 8. That'll be our color 8. Want a pixel, PF pixel 16, which will be our 16-bit color, and a PF pixel 32, or you can also do float for our 32 bits per channel. These are all going to be stored there. We want our vibrance amount, which will be like 0 to 100, I think. Maybe we could even push it a little further. For this, I'm just going to use a PF FP long. Call that Vibrance. Just so I don't get confused, I'll call it Vibrance amount. And then we have a gamma. Use the same data type here. Actually, then we can just do this. Gamma. I think we can actually just keep these as without amounts. Gamma, and then we'll need, for the fill background, that value is going to be a 1 or a 0, or true or false. So you can have a bool or an int. We'll just say int fill bg int. That will be 0 if it's unchecked, 1 if it's checked. So now that we have these, we need to go into our main CPP file, and we'll go to the param setup. And inside of here, we're going to build our UI. We're going to first need a color. So I'm just going to move this pre-inserted color one up to the top here. Instead of using a string from our strings file, I'm just going to call it color. The default color can be whatever you want. In this case, we're just going to use white. We should probably do something a little bit different. Let's do that. That should be like a blue-green, so like teal, I'm not sure. And the disk ID for this is color with a U. And then we need a slider for our vibrance, which is correct. Call this vibrance. Instead of using these macros, I'm going to set the mins to 0.0, max to 100.0 for now, and defaults to 100.0 as well. Precision, probably just need tenths. And then this is the vibrance disk ID. Then we need a gamma slider. Actually, we're not done with this yet, apparently. Vibrance disk, I need to spell correctly. Now let's do the gamma slider. This is going to be max 3, I think, should be good. And we're going to use a few more bits of precision here. Default will be 1.000. This is tenths, hundredths, thousandths. And we're going to be using the gamma disk ID. And lastly, we want a checkbox. So we first need to clear our struct. Then we'll say pf underscore add. We'll say checkbox x. First thing we need is a name. The name is going to be fill bg. The default, I'm not sure if it's true or false or 0 or 1. So I'll just say true for now. Flags, we don't have any right now. ID is our fill bg disk ID. Let's go ahead and peek the definition of this and see what value we need to provide it. It uses a bool, I believe, so yeah, we're good. But we want to actually false to start. Now, this should work. We have missing info here. This should be vibrancy info now. In fact, I'll just replace all our gain info with vibrancy info. Replace all that. And there's no gain thing right now, so we'll just get rid of that. Get rid of that. And did I delete too many? Yeah. Just gonna delete that whole thing there. Vibrancy gain is undefined. That is correct. Let's just remove that line. I think, are we good to build? Alright, so now we can see if this is actually going to load our interface or generate it the way we want. And then we can start working on the functionality. We'll also probably want to make a little test project. Something with transparency, ideally. I don't think any good elements on me. I can go to production crate and grab one. And this is the fun part where we see if we remember any of our passwords and things. Cool. I'm just gonna grab probably some fire. And this is fine. We'll use a 4K fire just so we can use lots of quality, I guess. And while that's downloading pretty quickly, let's go ahead and basically just apply this to, actually, we got a second left. That's unexpectedly fast. Let me import. This is a new computer. I hope I don't need to install QuickTime. That'd be wonderful. What's it called? Footage crate. Okay, we're good. Alright. We're going to save this and just call it vibrancy testing. So that way we can load that back up anytime. Now if I go to NT Productions and click on vibrancy, you can see we have our color, which is set to a teal, our vibrance, and our gamma, and our fill background. I think this is going to be a good starting point, and now we can start coding. We need to decide if we're going to use regular render or smart effects. If you're not familiar, regular rendering is basically just mostly applicable for 8 bits and 16 bits. And smart effects, or using the smart render, basically allows you to use floating point 32 bits and accommodate for a lot more things. So right now we're getting a black image. If we check our info box, so tell us the pixel values, which are currently just 0 for everything. So that's because it looks like we're using a regular render function. So let's do that for now. We can maybe upgrade this in the future, or just push that to GitHub or something. So right now in our main render function, it's dealing with 16 and 8 bits per channel possibilities. And in our simple gain functions, which does the pixel processing, we're doing nothing right now. What we want to do is just make the output pixels the same as the input. So I'm going to say outp.red is equal to np red, and we're just going to do this for each channel. Red, green, blue, and alpha. The reason we're doing this is simply to allow us to see the original image, because I think what we're going to start with is our gamma. Control Shift F5 to restart that. And now we should just get the same as our input image, which is good. It allows us to start moving forward with our sort of image processing and manipulation. So we will load up our previous project and apply vibrancy. Now you can see we're left with our original image, which is exactly what we want. And now we want the gamma to do something. If we go online and just type in gamma pseudocode, there's lots of resources for image processing gamma, and it's very simple here. This is basically the algorithm to calculate it. It's I divided by 255 to the y. The pseudocode 1 divided by gamma. Is it 1? It's 1 divided by our gamma value, gives us the correction amount, and we square it by that. I've programmed this many times, and I could just scrape the code, but I kind of want to make sure I understand it better, and that will help you guys understand it more. So the reason it's multiplying these by 255 is just to normalize it, but since we're starting with 8 bits per channel, we don't need to do that. It's already at 255 normalization. So if we just take 1 divided by whatever this is, and use that as the power we take our pixel value to. Okay. For now, I'm going to do this in my simple gain function, which we should really just rename this as gamma function. And then we'll change this in here. That way we stay organized and we don't get confused, which this will be relatively quick for a plugin development, but it'll be good. So now all we're gonna do, we need our gamma value. We need to use our vibrancy info, which will contain our gamma value. So say fp long gamma is equal to this GIP pointer. We want the gamma and I forget how exactly we need to. Oh, I also need to be doing this in the 8 bits for now. I forget if we need to pass something here or if it just interpolates it. Oh yeah, we need to do it before here. We're going to populate this GIP object with all of our param values that we need. So GIP dot color 8 is equal to our params vibrancy color, and I have an actual little personal guide for all of the UI elements. I just need to pull it up here. It basically tells me how to access each of the values here. There's the data types. Should have it more organized, but it's not. Okay, so for a color def, it's .cd. So we're going to get the u.cd.value. And then for color 16, We can just make a function that converts it to 16-bit. So we'll create a function called like convert color 8 to 16. Probably not the best name, but we'll send in this color 8, and now we need to define this. We're going to return a PF pixel 16. That's the function name. These are bounds. Too many arguments. We're going to be taking in a PF pixel 8. We'll just call it color, or input color. Then we're going to create an output color, which is a PF pixel 16. Our output color dot red is going to equal our input color dot red and the conversion. So our bounds of a 16-bit color, the number is 32,762-ish. I forget. I made a tutorial on this. I should know. Let's see if I still have the project file for it. Pixel ranges for different 32,767. So we're going to use that as our scalar. We're going to divide that by 255, and that's the number we need to multiply by to get our 16-bit color. Alright, I'll do that for each of the channels. Red, green, blue, and alpha. And lastly, we need to return our output color. And that should be good there. Back inside of our definitions here, we can continue on with our other values. We have our GIP dot Vibrance. It's going to be equal to params Vibrance C Vibrance. What am I missing? Oh yeah, we need to get the slider value. U dot fs underscore d is a float slider dot value. Then we're going to get the gamma, which is the first value we're reading in. Params Vibrance C underscore gamma. We're going to grab the same thing, u dot fs underscore d dot value. And lastly, we're going to set an if statement. If our params Vibrance C underscore fill background, if that, what is the value for that? I shouldn't have just closed that. It's a checkbox, is a BD. I believe it's supposed to be a bool. So if that is equal to false, then GIP dot fill background int is going to be equal to 0. Otherwise, it will be 1. So I think that should be good for our setup there. What I'm going to do now, inside of our gamma function 8, I'm going to come in here and I'm going to set a breakpoint and see that we're getting there and have the correct values. We've got an error. So this wants me to probably cast this to the proper data type, but to get around that, I'm just going to go into my properties. I think it's under C++, yeah. Treat warning as errors, turn that to no. Now we should be good to go. And then if we get the right values here, we can pretty quickly program our gamma function. And then we're gonna do the easiest stuff first, and then get to the hard stuff, the juicy stuff. So let's apply our not that one. Let's apply our vibrancy, and our breakpoint is telling us that let's actually move one past it. Can we step over? Okay, well, it's saying the gamma coming in is 1.00, which is great. Oh, I have to realize it's doing this for every pixel, so I'm just gonna go past that. But we know the gamma value is coming in accurately. So now let's apply that math algorithm here. We're going to say, we can actually just say, remember how this gamma correction needs to be 1 divided by gamma. We'll just do that here on our gamma definition. Looks good in parentheses. And we need to set these to that power. Now, in a lot of programming languages, you have to do something like that. But I believe in C++, we just go pow. And then we have the original number. The second argument is the power we take it to. We want to take it to the gamma power. So just power all these. We're just powering the incoming pixel value for that channel by our 1 divided by gamma, really. We'll do that, I think, even for the alpha channel. And now let's test it out. Hopefully it's a nice, easy programming for that, and it will just quickly work for us. And if we do a 16-bit version of this, we will need to probably use that scaler as well. Okay, if we apply, now let's change the gamma, and we're getting some funky results. This is most likely for a few reasons. Well, one, the gamma is in the opposite direction, so maybe we don't need 1 divided by. The other one is in the opposite direction, it's doing all this, which if we look at the pixel values, pretty bright. I think what we need to do is we may need to cast or clamp these values down. First, let's just do our gamma here. We don't need maybe 1 divided by. And let's try that. Alright, we'll apply the effect. Okay, now we have it going in the right direction, but we're getting this weird color tinting thing. And this is usually due to not having the right values for your pixels. We're not converting this in particular, so we don't have to worry about this code here. Looking back to this, actually, the data type is an AU char, so what I'm going to do is cast these to that. And let's see if this works. Sometimes it just takes a cast, and that will usually fix it. It's usually actually only with the lower bit rates like 8 and 16 where these issues come up, because with 32-bit floats it kind of can do whatever. You can get some weird rainbowing effects, but usually less to do. Okay, we'll apply vibrancy. Now we're getting the same effect. When we decrease it, it's good, but increasing it, still not good. Let's debug time. I can pull up another project and get the accurate working code. Yeah, let's just do that. It'll be real quick. I've got gamma functions for all the bit rates. It's just sometimes it's fun not to use them. Gamma. Capital Gamma. So in this I have doubles for the values, and then I cast them to the AU char. I also clamp them. So I'm gonna copy this. Why don't we just copy this whole thing? Okay, so I'm just gonna copy this whole function. It's basically the same, except the only difference here is that it's using a double variable for the RG and B values, then it's applying the power, it's clamping them if they're higher than 255, and if it's not a solid number, it's just going to make them 0, and then we cast them at the end on the output part. That's pretty much right. If this doesn't work, I don't know what will. It's also for smart renders that there is potential for that, but this should be the proper way to store and cast these values. Apply it. There we go. That's behaving more accurately. It's already pretty bright, so wish my window would stay open, but are there simply no blues in this to... Yeah, I guess there's a lot of these pixels with no blue, so it doesn't actually go full white, it just turns yellow. Interesting. I think that might be accurate of how the color representation of alpha works, but now we've got that working. If you go up to 16 bits per channel, you'll probably notice that it's not working because we need to update the code for that. So we will do that really quick. We are going to copy our code from here. Or are we going to... Yeah, we can just use a multiplier, I think. I'm going to paste the 8 bits per channel code into the 16 bits per channel section. Instead of 255 as our clamp, we need to use 32767. The data type for 16 bits is an AU short rather than an AU char. and I like to normalize it like this algorithm suggests to 255 or 8 bits, and since this is that, we need to divide it the other way in order to get that scalar. So what I'll do, we need to bring the pixel value or the channel value down to be normalized. So I'll just copy some of this. We're going to multiply this incoming 16-bit color down to 8 bits by doing that. And then after that, we're going to multiply it back using, I guess, the other way around. 2767 divided by 255. Just grab that. I think that should be good. I'll just copy this to the other channels. Yeah, let's try that. Right, go ahead and load up the plugin. Go to 16 bits, change our gamma. Now you can see we are getting the same result as our 8 bits per channel. I think in this tutorial we're going to just stick with those two, but it still should kind of work in 32 bits. I think it will try and use the 16-bit code, so that should be good. It's not necessarily a tutorial about using smart effects, it's more a tutorial about making a plugin. So that is working. Gamma, that's all checked off. We can take that off our list if we want. Next up, fill background with black. With the way I described this in the beginning of the video, and that's why I'm using this with transparency. If our pixel is transparent to a certain degree, we want to replace that with black. We want to basically do the equivalent of putting a black solid in the background, which is like just doing a solid composite sort of. So we first need to decide what that threshold is going to be. Let me just make sure that we're still going. Cool. We need to figure out what that threshold is going to be. We could just say, let's load up our info palette to see our pixel values. We could just say here, if our pixel value is below 1 at all for alpha, then just make it black in the background. But I think that would cause an undesired effect. Maybe we can try it first and then tweak it. But maybe we could also say only fill in the values that are completely transparent. And I think I'm going to actually do this in my gamma function just to save space. So the way we can do that is just by checking the value of the alpha. And the gamma function is being applied pixel by pixel. It's using the iterate 16 and iterate 8 suite, which will iterate over all the pixels on the layer in which it's applied. So doing this on a pixel by pixel basis, let's say if alpha is 0, we'll make it a black pixel, which is a specific color. It is an alpha of 255 and 0 for the other values. So inside of gamma function 8, let's say if np alpha is equal to 0, then we want to do something. Otherwise, use the algorithm we were just using. If it's this, if it's a 0, we want our alpha to be 255, and we want everything else to be 0, which is black. No luminosity from our RGB channels, but full opaqueness on the alpha channel. So let's try that out. Hopefully it's that simple. I could be wrong. You'd think it would recognize my last used plugin by now. Maybe if I close it from the X. I didn't even... Wait, do I have the code for that yet? I just said if alpha is 0, then do that. I didn't say if I check it. Okay. It's because I have cached frames. Anytime you have cached frames, it can make you confused. So let's purge that. Let's purge that. So now it should just be whether it's checked or not. So this is what our effect would look like right now. You can see that's not exactly desirable. That's not really filling the background so well. So what can we do to make this better? I think our original assumption to say if the alpha is even 1% transparent, we should make the whole thing black. Or not the whole thing black, but make the whole thing opaque. It doesn't have to be black, right? It just needs to be opaque. So maybe let's try that. We actually first want to check. Let's grab. Let's make an int called bgint, and that's going to be equal to GIP, and grab our fill background ints, and okay, if our background int is equal to 1, we want to fill the background. If it's not equal to 1, then we want to use just our gammaed values we gave it. If it is equal to 1, we need to check the alpha pixel. If the alpha pixel is opaque, do this process. So how about if np.alpha is equal to 255, or is not equal to 255, then we're going to use this code. Instead of making these all 0 though, let's use the same RGB values as the input. Green and blue. We can get rid of this now. I think this logic should work. If the alpha is 255, we're just going to use the gammaed values. I guess these need to be gammaed too, do they? I think this is the same. I think we need to use red, green, and blue, but we just make the alpha 255. I think maybe the fill background, better stated, is to remove all transparency. Censorship, basically. Let's see if it remembers my effect this time. Yeah, cool. Alright, clear the cache. Fill background is empty. Let me check it. Okay. It's looking better. It's a little intense. I'm trying to think if there's a more subtle way we can kind of feather this out. Like the idea is working now. It's filled. I mean, if you want, you could basically take this here You could take the code and define a specific color you want instead of black. Right now it's just taking the input. Because these pixels here had no pixel information, they were just set to 0. It's not because the background was black, it was because they were transparent. So it looks desirable as we wanted, but look how much more like stuff is up here. It's so red, but in the original, not at all. This is what it should technically look like. I think I know the solution. So instead of saying, if there's any transparency, remove it. Get rid of it, make it fully opaque. No, that's wrong. Because if I put a black solid in the background, it's the same, right? This will take a second. What it's doing is if there's any luminance, it makes it like fully visible. It makes it super hot. Like everything becomes orange and red. But how do we need to change the pixels to make it lesser so? Because the goal is to completely remove the opacity. Why is the red being boosted as such? Let's check our algorithm. Checkbox is checked. The input alpha. In none of these areas have like a fully opaque situation going on. But some of them are maxed out on the red channel. So what it's basically doing is making all the alphas the same. This is a tricky one. I feel like the answer is simple, but it's eluding me. We make it fully opaque, but what if we multiply the input value by like the ratio of alphas? What if I take the red channel and multiply it by input alpha divided by 255, which is the percentage of like the intensity, I guess? It's just an idea. Let's try it. The idea is that if the alpha is less than 255, it needs to be 255, but maybe we need to reduce the other channels if that's the case. Otherwise it just becomes really weird looking. And as we reduce the luminosity of those other channels, hopefully that will give us the desired look. We clear the cache again. It's a very short clip. That's probably a disadvantage here. Oh, that's not quite what we want. So now it's almost like we're just getting the super bright hot spots. Not what we want here. So one way I like to debug this stuff is, the nice thing is we can actually look at these pixels and look at their values. Here's what we should do. We're going to pick an XY coordinate, grab its pixel value, and then we're going to add a solid background behind it and see if it's the same. So let's just say 11. I want to pick something up here. That's a good spot. I'm going to write this down. $22.50 is our y, or our x, and our y is $11.25, and that value is going to be $2.55 for R, 43 for G, 0 for B, and 71 for alpha. Now, if we apply a black solid behind it, which is the effect we're going for, I'm going to pre-compose. Or is it already recognizing it? Okay, that's cool. So we need to go back to 2250x. 1125, which we're already on. Now the value is 71, 12, 0, 255. So there's quite a difference here. Let's see if we can find the ratio or something. The original alpha was 71, and the final alpha was 255, which is 0.2 of the intensity. Let's multiply 255 by that and see if we get the new red value. Invalid input. Uh-oh. Let's try that again. $255 times this guy gives us the value, which I thought was the algorithm I did. I must have inputted it wrong. My idea was right. No, that was the input. And multiplied by that. Is it too intense? It's probably something simple. So if the input red was 255, the input alpha was 71, we divide that by 255, multiply that by the original red, it should have given us 70, but it's only giving us the super bright stuff. Do we need to cast this as a double maybe? Just guesses at this point. Once we get done with this, we can move on to the main part of this, which is basically figuring out how we're going to tint pixels, and the vibrance will control the intensity of that tint, essentially. And depending on what kind of algorithm you choose to use, if you make one of these on your own, the way you integrate that intensity is a little different. Okay, no information. There we go. Okay, we're still looking like nothing's showing up. And pixel-wise, everything's at 0 or white. I'm going to do this. Actually, this needs to be back to 1. See if we can figure out why the math is messing up here. It works out on paper, but it could be a simple type issue. It's also probably going to give us a lot of bad input pixels. Can I change my X and Y things here? I don't want all these empty pixels though, that's the problem. I want to only get alerted if let's pick a specific pixel. If XL is equal to, what was it, 2250, and YL is equal to 1125, then I'm just going to say test is equal to 1, set a breakpoint, and I'm going to use that in order to get past all of the transparent pixels and things that it's going to go through and breakpoint. I just want a breakpoint when there's important stuff that I can actually run a calculation on and look at why the values aren't calculating properly. Okay. Okay, we got our breakpoint. Our red value is 255. Our green value is 43. Oh, this is the exact case. This is perfect. This is the exact case I just worked out. Oh, no, it's not. The in alpha is different now. In alpha is 12 instead of 71. And so, that's our issue. NP alpha is 12, but when we actually run the calculation to divide these, it's returning 0, which is not cool. So that's clearly our problem. Should I cast it first? What does it think this variable type is? Should have ignored. Double multiplying an AU char divided by an int. Perhaps we shouldn't do that. So, well, we can try that, but I think ultimately I might need to cast the input alpha value. That might be the issue. It may need to be cast first so we can divide it, but we'll see if changing an int to something else works. That worked. I was like, why is it not doing anything? It's because it's working. All right, cool. So just a bit of casting was required there. That's a little annoying, but it works. That's good. We need to do the same for the 16 bits now. So we can just integrate this algorithm pretty easily. Just paste it above here. And instead of 255, we need that 32,767. We need to define background int. And we don't need this anymore. Let me change this. And changing AU chars to AU shorts. With that, I think we're good for 16 bits. Let's try it out. $16 bits per channel. Looks like it works. So we got those two features done now. Awesome. Now for the main meat, the color and vibrance. So I'm trying to really decide myself how I'm going to do this. Is it going to be take a pixel, change the RGB values to be exactly what we want? Because that's just gonna make very solid, strong colors. Which maybe I guess is what we want, but we want to pull off a little bit from that. So what we can do to illustrate this? First, we need a second function. We don't just want to do the gamma. We also want to tint the color, which we should do first. We'll just say change the name to Tint Function 8. And I'm just going to copy and paste our gamma function 8, change it to tint, and we're going to strip out this code. We just need our 8-bit color, so pf pixel 8 color is equal to GIP pointer color 8. So that's our tint color that the user has selected. Now, to illustrate how strong this is going to be, let's grab all of our output channels and set them to the according channel in our color object. So outp red is equal to color.red. Let's do this for all the channels. Where's the semicolons? Something like that. And this should be a pretty strong looking result, but that's what we're going for. Sometimes it can really help to, if you're trying to figure out like how we were doing the transparency and making it fully opaque but appearing like there's a solid composite basically. Sometimes making a dramatic change, like making it totally bright red or something, can really help identify that. So I'll go and clear the cache. Cache doesn't care if you've changed the parameters. It's not doing anything. Let's set a breakpoint. It recognizes the color. That's good. But the output's just not being done properly. That should be working. I don't see why it's not. I don't think the gamma function should mess that up. It's interesting why that's not changing the pixels at all. First, just double check that we're actually running it. Oh, so I think we're overriding the output. We need to do this. Do we need an intermediate temp? No, so for the first function we're going to run is the tint function. The second is the gamma function. But what it's doing is it's taking our input layer, the raw input layer, applying the tint, and sending that to the output. Then it's taking, again, our raw input layer without any effects or anything, and it's sending that to the output layer with the gamma function. That gamma is totally overriding the previous send here. So instead of using the raw layer data on our gamma, I'm going to use the previous output, which contains the tinting. So that should work. Just a matter of sort of compositing order, really. Right, let's try that out. And that's the dramatic effect I was talking about. As you can see, it's tinted every pixel teal. We didn't put any if statements or anything to check for that, but we know we're in this function now. Every pixel is now that color. A couple things. Our output alpha is going to be our input alpha. We don't want full opacity because they might want some transparency. I have an idea similar to what we did with the gamma, where we divided the original alpha by the maximum amount of alpha, which gives us sort of the luminosity difference required to calculate. What if we do the same thing with the distance between our input channels and the tint color channels, and then multiply that by the original color? Let's try this. Input red times color red okay, let's say our input red is 255, right? Like our example. Then, if we divide that by the red of the color, we're using a teal which has 0. It gives us 0. That was not what I desired there, but 255 divided by 0 is undefined actually, but okay, let's do a different example. In that same color, we had 43 for the green. We take 43 divided by the green of our tint, which is 255, the maxed out value. That means our green, I think it should be the other way around. Is it 255 divided by our green? It's 6 times less green than it should be. So then we divide by that. We multiply by that. See, this is tricky, but this is our main algorithm here. Let's use that same logic for our other one. 255 divided by, no, our final red was 0 divided by our red value, which is 255, which gives us a non-undefined 0, which is, I think, what we need. Logically speaking, hopefully that works out. So 0 If it's 0, I think it's a different case, because if I did 255 divided by 1, we know that's the furthest. No, it's 0 distance from where it needs to be. If we're tinting, okay, I think I'm confusing myself. So the algorithm, I think, is the tint color channel's value divided by the incoming pixel's same channel value. So let's say the blue channel needs 255 to be teal, and the incoming, the green channel, and the incoming green channel is 43, so it needs to be multiplied by that. Let's try it. Let's use an A-long multiplier. Okay, first time we're going to use multiplier. It's going to be equal to color.red divided by NP red. Alright, we're going to copy that below each of them and change the channels. Oh no. And then we'll take the multiplier and we multiply the input by it. Just an idea. Let's see if that's a dramatic departure from our completely teal screen. We may need to put in if statements just like before, where we don't want to mess with the alpha or things like that. Let's see how this looks. We're getting an error here. It's a pointer error probably. We need to find what it's having issue reading here. Is it because we're dividing by 0? Integer division by 0. So if NP alpha is greater than 0, do this. Otherwise, just use the input values. Let's try that. And once we get this working, it should be pretty easy to tweak the algorithm to fix it, and then relatively easy to include like a 0 to 100 percentage to decrease or increase the strength of it. Okay, I'm getting another error. I'm just say +1, right? The input is sometimes 0, and we can't divide by 0. So if we just add 1, I don't know if that's legal, mathematically speaking, but we're going to find out. Sometimes you got to get a little bit creative. All right. Hey, look at that. Look at that. Oh, look at that. Look at that. It's almost working right out the box. I mean, there's some issues, yes, but look at that. I'm pretty happy with that. And that's just like a quick algorithm idea. And if we start combining things, look at that. It still works. Want to increase the gamma afterwards? You can. Okay. I think that's good enough to move forward, and it's very sparkly in there. Is that because the gamma? I think that's just how it is. That may be an issue we need to fix. It is also 4K, but I don't think that has to do with it. So it is working generally speaking. Why we might be getting these very sharp dots, that's something we definitely might need to fix. So they're in many different areas, which is the problem. I can't just say, oh, because look, they're not being clamped. Some of these values are greater than 250. Oh, I guess 255 is our limit, never mind. They're just very opaque. The general image is tinted the right color, though. It does have some striations of various different colors. Look at that. I guess only some of the tints are doing that. The red, the green and blue look good. But the red seems to be... like, look at that. That's a straight tint Vibrance right there. And you could just be like, oh, I want to increase the gamma. Gamma's not working up to there. Interesting. That may be another thing we need to fix. So, we're getting weird issues with the red channel. How could we fix that? Let's first have a look at it again. Like, why in this case is it tinting two different colors? Looking at the original footage. It might have to do with the alpha. The spots are really very strange, though. I've had issues before at the edge of things like this, or like on tinting things orange and red before, but I haven't had little spiky issues like this. This is a prime example. This is almost like a different kind of pixel art. Yes, it needs to be tinted red, but why are they... It's like rejecting some pixels. Is it because of my alpha check? If alpha is greater than 0, this one's tricky. I'm not sure if I'm gonna have time to dive in and solve it, as I can think of a decent idea. That might be the advantage to live streams in the future, is live help. Okay, one thing I'm going to try is, do I get the same result if I turn off gamma? Is gamma affecting this in a negative way? Sometimes turning off your various functions you're applying to image process can help to identify the issue. And in this case, it may or may not be causing the issue. It will help us at least identify where the issue is coming from, which will make it easier to debug what the issue is. Okay, so looking good at teal. But there we go again with the, as soon as the blue channel dips, it seems to have this issue. So we know it's not the gamma. That's actually like a good thing. Looking at our actual gamma function, we had what background int. The alpha is not that. What are the chances I need to cast it? At least we'll do it for good practice, right? Another thing I can try and modify is if alpha is greater than 0, is that the logic we want to use? The areas where alpha is 0 are the ones on the outside of the fire where it's completely transparent. So everything else is going to get processed. Might there be some areas of 0 transparency in the middle? Or sorry, 0 alpha, not 0 transparency. Doesn't seem like it. So casting didn't fix anything. The thing is, it's making a lot of these pixels totally black, where they were pretty fully bright at a time. Is it the green channel? Why is the green channel behaving like that? Take 0. I'm wondering if I'm coming into issues with the input as well, or the input being 0. Oh. No, that was just in the red. Is it because this? Oh man, if this is it. I didn't use the color. No, wait. $255 divided by the input color. But then we want to multiply the input times that, which I haven't been. Somehow it's just maybe gotten lucky on the green and blue tints. Let's try that. spend a few more minutes debugging this, but if not, I'm going to move on to the Vibrance part. There should be something really simple. I'm going to go ahead and clear my cache since it's getting pretty full. It's still happening, but some of the color banding feels a little bit better. I actually kind of liked the previous algorithm better. I might go back to that. What I was doing seems to be more additive, so maybe if I just change this to color times the multiplier. Maybe we just need to go forward with a more direct tint. Subtracting is hard though, because sometimes you have a channel that's not important with the tint, and then maybe that gets calculated and messes things up. I don't know why it needs to behave like that. Okay, I have another idea. I'm gonna keep this just in case. What I'm gonna do, copy and paste this. I'm gonna keep the alpha the same as the input, but for these I'm just gonna use the color objects. So color red, color green. This is probably going to be really strong, just like before, but it's not going to be the whole screen. I mean, this is pretty much what I was already doing, but whatever I'm subtracting or doing to it isn't enough. I don't want it to be just a straight tint. I want it to be variable with shades and highlights. So as you can, that's a straight tint. I guess it still has some luminosity. Oh, there we go. Okay. So I guess we need to be more direct like that. But you can see gamma is going to do that because it's already so bright, but you could maybe add some extra additional things to that, but maybe it's not necessary. You can try and mess around with that idea a little bit if you want. The code is going to be on GitHub. I'll probably upload it during this video. Now, Vibrance. It's our last thing. We're going to create a variable type along, just because. Say Vibrance. It's going to be equal to our GIP pointer dot Vibrance. And Vibrance is going to be 0 to 100, so it needs to be a percentage. Anytime we want to get a percentage, we just divide it by 100, and we get what the multiplier, basically, to calculate that percent is. So our Vibrance is going to be equal to our incoming Vibrance value from the slider, divided by 100, and then we can simply multiply each of these, I think, by that Vibrance. Let's try that out. I'm still really curious why we were getting those strange specs. Maybe it's because I added +1. There's probably a more desired way to deal with zeros. All right. So now if we change, it doesn't like that at all. Let's see what value we're getting. 1. So the incoming value here is 100, and that's not the same. 100 divided by 100 is 1, so the tint stays at 1. Okay. But if I change it to 50, what do we get? 50 divided by 100 equals 0, of course. Double. See, one of the hardest parts about C++ is data types can really mess things up unless you've got some experience knowing how those data types get you messed up, which you can find through breakpointing everything. Okay, there we go. That's kind of just changing the opacity though. So we're going to do one more thing. I think because we're multiplying our vibrance on all the channels which constitute the entire luminosity of the image, as our vibrance approaches 0, it shouldn't be approaching 0 luminance, it should be approaching 0 tint. The full amount to reach 0 tints means that the channels need to converge upon the same value. In order for something to be black and white, the red, green, and blue channels are all the same. So there's that idea, and there's also the idea of finding the important channels. The important channels of a teal are green and blue. So just subtracting the vibrance from that. We could try this practically by just removing that and trying it with the default teal color maybe. I would say our color value is also finished here. Alright, so let's reduce the vibrance, and that's reducing still all the pixels. So in this case, this is a tricky one. How to increase the intensity of our tint? Well, what we're doing is just straight up replacing the colors. So how do we reduce that and go back towards the original colors? That's the question. So if we have 0 for our red channel, or no, I guess we start off with. This is going to take some experimentation, I think. So we have our original input values, which are in our MP. Maybe we do need the difference that we were, or the division here. I don't think that I want 0 vibrance to mean, or do I? Do I want 0 vibrance to mean black and white and 100% vibrance to mean color? Or do I want 0 vibrance to mean original image and 100% vibrance to mean tinted image? I'm going to let you think about that while I get some water. Did you find the answer? Because I didn't. I guess it's really up to us how we want to do this, but this right now is the same behavior as just reducing the gamma. So and because in this case, in the teal case, there's only two channels which we're changing the vibrance of. Those are the only two channels with luminance. So what we'd ideally need to do is add to the red. I'm sure someone has an algorithm to calculate this already, but what if we take our input pixel channel value, like our input red, and let's take our previous example here. Let's say our input red is 255. Our tint color is teal, which has 0. You can't divide by 0. I was trying to think, maybe if we reduce the vibrance before we tint. Like if our red value was... This is a tricky one. I feel like we should be able to do it with some kind of multiplier, but maybe not. If I wanted to just make something black and white, do I just find the average of the three channels and then set them to that? And then we need to know, do we converge towards 0 or 255? Okay, I think we need to identify the important channels. The important channels are basically something I've used previously. Actually, in this is important. And what it does is it takes the incoming color. What's the actual function do? Takes the incoming color and it basically finds if it's important or not. The logic, I don't exactly remember because I wrote this a while ago. But let's see if we can quickly... Basically, it has code to check what's important, but what is mathematically defined as important. If red is less than green and red is less than blue, the least important int is that one. Okay. Let's try it out. Sometimes you gotta scalp. The channel int is 0, 1, 2, 3. And my other code in here checks what? Just a bool. And if the bool is true, if it's important, we subtract. This is for a similar tinting algorithm, but it's more complicated. So if it's not important, use the original color. If it is important, do something. In our case, I guess just reduce them, right? I'm going to copy the other variables in here too, which were green channel B, red channel B, bool. I guess we can calculate these at the beginning. I don't want to load Premiere right now. Let's do this. Just have color 8, just color. Now we'll say if red channel B is equal to true, do something. Otherwise, use the original. If green channel B is equal to true, do that. Otherwise, use the original value. Or no, use the color value. And if blue channel bool is equal to true, do some maths or that. All right. This may or may not do anything. If it doesn't, we're just going to leave it where it is and have a more basic plugin. Just allow you to mess around with it if you want to. So, if that's true, let's just first try this. Perhaps it'll give us an undesirable result, or maybe it will be very explanatory. I wonder how many times people have seen this dude, especially me or any other developers. So that's still just tinting it like that. Let's try a different. See, now it's not doing anything. Interesting. That's not quite doing what I want either. Instead of multiplying by Vibrance, which is just a straight calculation, what's the difference between the input? Oh wow, I'm using the green channel. That may be one of my issues. Hold on. Let's try that again. Anytime you have a big mistake like that, you should definitely test again. I still think it's going to just reduce the luminosity, not the actual tint amount. This is giving me some respect for people who make a simple black and white plugin right now. That's a little more simple, but like, you know, it makes sense now. It's a little difficult. Some things I don't understand. Opacity. Alright, so it's working the same for all the channels now, except for apparently pure red. That's annoying. So there are bugs, of course. There's always going to be bugs, but we're basically building a full plugin right now. Last ideas of what we can do here. Okay, let's say our input channel's red, 255. Can we clear this place? Our desired red is 0. What if we take the difference and multiply that by our vibrance amount? the difference would be 127.5. And then we subtract it from the input. Let's just do an experiment here. Just take the color red, which is 0. We want to get the difference between our input red and the color red, which in this case is a full 255 in our test case. And we're going to divide that by 2. Then we're going to take our input. No. We want to take our color and subtract this. Let's give this a shot. This is at least like a more fun part about debugging, is actually like seeing the visual changes. Sometimes you're just looking for spelling mistakes or knowledge you don't know, but in this case you can actually see the difference and check the pixel values and mathematically prove or not whether what you're doing is wrong or not. So I'm not using the Vibrance thing at all right now. It looks much better in that area. Actually, I'm kind of digging this. It's a little bit stylized, but now we need the Vibrance still. So as we change the slider, it's going to change the value of that. Let's try it right here. I actually kind of like how the look is. Maybe you could even make a checkbox where you have two different, or a drop down with two different options. One of them just using a straight tint, the other one using like a more additive, subtractive method like we're trying right now. Clear the cache. Yeah, that's not quite what we want. I don't like how dark it gets. I mean, it's kind of accurate, I guess. So to control the vibrance better, to control the tint better, I multiply? Okay. So 127. Put it here. First we make the required tint color a little bit less intense and then do this process. If this ends up just not looking good, I think we'll go back to the full tint. But it's good to experiment with these different methods, and I'll probably keep them in the code. So I like how bright some of these get. Once it reaches below a certain point, it's too dark for me, though. I don't know if that kind of vibrance change is what I want, because it's really changing colors. If we're going to make it black and white, if we want to converge towards black and white, we need to define like a global black and white point almost. But I think I'm gonna get rid of this part. Maybe we need to keep it simple. You could quite easily go in and add more functions similar to the gamma function, but instead of powering the pixel values, you could just multiply them by 2 or use that as like a brightness slider. But the gamma is also supposed to kind of do that. I think for now we gotta stick with this because it's working and we can always make modifications later. The last thing I want to check on before we finish up our 16-bit and finish up this project is I want to double check our gamma here. It's not working super well. So I'm going to keep this code in here as well, just if you want to use it. Gamma. I mean, are we already maxed out on our pixel values here? Because if that's the case. It doesn't seem to be. Background is indeed checked. Power requires 2 doubles. Should I cast that to a double first? Or is it because we're crushing it? This is my last thing I'm going to try before we do the 16-bit code. Sometimes you gotta set a stop point, otherwise you're going to be up till 2 in the morning every morning. Or later. Okay, so now we're just doing a few last minute things to try some stuff. We need to cancel this. It only cast one of those. The issue might be having the background check in the gamma function. Like, I feel like, well, it was unchecked in that case. Oh yeah, of course, that is a C-style cast, huh? Because that's how they teach you. What if I turn off the clamp? So in order to make this work for 16-bit, we're just going to be using the same code, just with some different values. Instead of 255 being our max, then becomes 32,767. Okay, now it's behaving weird. What happens when you don't clamp it, I guess. Are we not getting into this? It's not working, so I'm just trying to break points and see if I can find the issue. Let's also get our background int, make sure that's valid. Because yes, the math might be there, but if it's not going to the right if statements, that's an issue. Fill is 0, that is correct. So it seems that's going to be where we're going to have to say take a break from that for a little bit. Lastly, we're going to make our 16-bit one, or 16 bits per channel. We need to update the pixel type to 16. It seems to be color 16. What, you don't have color 16? Oh. We're actually going to need this code as well, which we can actually just use GIP color 8, which does exist. We'll use from a different, it just gives us the same data. And then we need to include this in our render. Put it before our gamma. Change the name to Tint Function 16. We need to use the output now in our gamma instead of that. Did not change the name. Okay, let's try it out in 16 bits per channel. Error. What's it called then? Tint Fun. Needs to be an iterate 16. Alright. I'm gonna make the repo for this too. We're going to make Vibrancy plugin. Simple Vibrance plugin. Well, we'll have a GitHub. And I can also just go in here. We'll do plugin files, source code. That way you guys have access to it. Now, lastly, let's do our 16 bits per channel look. Looks like our tint is working nicely. Our gamma, that's your homework. If you want to work on the gamma, figure out why it's not working. These other features are working nice in tandem though. And the vibrancy, if you have a better algorithm, we need to know. So that is our color vibrancy plugin for now. I think we'll add small updates in the future if you guys want to give some requests. That is great as well. Let's go ahead and put this in there. We're going to get the release copy of this if you just want to use it. Going to clean my solution and build it. Then to go get it, we go into our program files, Adobe Common plugins, and my build directory is in my own folder here. Oh, we got an error. Oh no. We need to ignore the warnings in our release mode. Build that again. There we are. There's vibrancy. You want the Mac version? I don't want to compile it right now. Source code. I'll probably need to close VS for this. We will throw in our vibrancy source code to there. One folder down. And as these populate in here, oops. Go ahead and main files, basic working extension, commit, and we will publish, make sure it's not private, and now this should be available for you guys. So if you want to go in and adjust it yourself, change any of the algorithms, fix the bugs that we found, be my guest and feel free to use the plugin for simple tinting and just expand on it a little bit, use what you've learned today and make it awesome. So that's going to do it for this video, guys. I hope you enjoyed. If you did, down below hit subscribe and the bell icon to be notified of new videos coming out twice weekly on the channel, and down in the description you can check out the GitHub link where this is currently uploading the project, and you'll be able to have access to that. And down there as well, you can follow us on Instagram to get updates on when other things go live. If you want to submit cool ideas like this for future coding challenges, come onto the Discord server, get help with scripting, extensions, plugins, expressions, and submit tutorial ideas like this one. But that's going to do it for this first very long version. Coding challenge. Yes, I kept that in there. I usually record like 10 of these outros. Thanks again for watching, everyone. We're going to see you next time.